how to implement this design, give an expression using PLA. First, I'm gonna create the K-map for all of them. Here we can see we have 4 variables right here, so it means we are going to have 2 power 4 addresses, 2 power 4 locations, that is 16. So we have to create a 4x4 K-map. Let's go ahead and create that. So 1 for the W, 1 for the X, 1 for the Y. Okay. Okay, let's do the W first. Here we have variables A, B, C, D. Let's put this on right here. A, B here, and then C, D right here. And then this is 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. And here we have the min term provided. That is, these are the locations of ones. We have a 3 at, we have 1 at a 3. Let's actually write the address representations so you can see it clearly. This is 0, 1, 2, 3, 2, 3, and this one is 4, 5, 6, 7, and this is 8, 9, 10, 11, and then 12, 13, 14, 15. We have 1 at 3, so it's going to be right here, and we have 1 at 7, that's going to be right here, and we have 1 at 8, that's going to be right here, and we have 1 at 9, that's going to be right here, we have 1 at 11, that's going to be right here, and then we have 1 at 15, that's going to be right here. Others are going to be 0. Now let's combine them and write the sum of product expression. Here 4 is, 8 is better than 4, 4 is better than 2, 2 is better than 1. We don't have any possibility of getting 8. The next thing we have to look at is 4. Can I combine any of them as 4? I'm seeing this one as 4. Let's combine this, and if I do that, what's the expression for this? You can see A and B are changing. A is 0 here, 1 here, changing, eliminated. B is changing, 0, 1, eliminated. And then C and D remains the same, so that's going to be an expression. And that's it for this one. Let's look at any other combination. So here I cannot combine these ones as 4. The next possibility is 2 right here. Okay, for this one, if you look at A, B, it's not changing because this is only happening in this column, so it's gonna be there. A is 1, so it's gonna be as it is, and then B is 0, so we have to do a complement for it. Let's look at the C. C is 0, 0, so it's also not changing. Since C is 0, we have to do a complement for it. D is 0, 1, eliminated. Okay, so this is the expression, sum of product expression for the W. Now let's look at X. Let's create the 16 locations. Okay, so here we are going to have the AB and then CD 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. And let's try the locations. It's going to be 0, 1, 2, 3, and then 4, 5, 6, 7, and then 8, 9, 10, 11, and then 12, 13, 14, 15. And here we have the min term provided. We have 1 at a 3, so it's going to be right here, and we have 1 at 4, that's going to be right here. We have 1 at 5, that's going to be right here, and then we are having a 7. I mean, we are having a 1 at 7, that's going to be right here. We are having a 1 at a 10, that's going to be right here, and then we have 1 at a 14, that is right here, and then we have 1 at 15, that's right here. Others are going to be 0, 0, 0, 0, 0, 0, 0. So the first thing is, can I combine any of these as 4? There's no possibility, I'm saying. There's no way I can combine this thing as 4. The next thing is 2. Can I combine any of these as 2? Yes, I can do this one. And when you are combining, make sure that you can, if you find a match, for example, let's say here I have 2 right here, right? 2, 1 on top of this. So if you can find a match in the other table, it's better, because in PLA the AND gates you can use is limited. So it's better to find the matches and do it. That way you're gonna need less AND gates. So here when we are doing it, we have to be thoughtful about which one we are gonna take first, because if you look at this one, I cannot combine this one with in any other way. I cannot combine any other ones. Only this one connect with this one. So I can do that first. And this one at the end, I can only connect with this one, right? So I do that one second. And this one at the end, I can only connect with this one. But this one in the middle, you can see I can connect with the bottom one or the left side one. So I had to be thoughtful about it. So I'm going to leave it right now like this, because if I draw the third K-map and if I find a match to it, it's better to create the match for it, because in that if we do that, we reduce the AND gate we use for it. Okay, let's create the third K-map and see if we are finding any match. So here I'm creating my third K-map with 16 locations. Okay, here also we have 4 variables, A, B, C, D, and then this is 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Let's look at the given values. We have 1, 5, 7, 11, 15. Let's put the locations first. This is 0, 1, 2, 3. This is 4, 5, 6, 7, and then 8, 9, 10, 11, 12, 13, 14, 15. We have one at 1, 5, 7, 1, 1, 5, 7, 11, 15. 1, 5, 7, 11, 15. Okay, others are going to be 0. Can I combine any of these as 4? There's no way. So 2 is the next possibility. Can I which way I go? So if you look at that one at the end, there's only one way possible, this one. So do that first. And this one also only possible with this one. Do that second. Okay, wait a minute. Yeah, do the second. And here you see I'm finding a match here. This one is second and third. This one also second and third, right? So instead of like you have other possibility of putting it down, like you can connect this one with the bottom one as well, but that's not the optimal choice, because you see if I connect with this one, I reduce the AND gate I'm using. So I'm going to do connection like this and this. That's why if you see multiple possibility of connecting this one, you have to leave it alone until you finish all the K maps. Okay, let's write the expression for these things. I have to write the expression for X and Y. Okay, X is what? The first one. Let's look at this. This one is only happening in one column. In that column, A is 0, B is 1. So both of them are going to be there. A is 0, I have to do a complement for it. And then B is 1, we keep it as it is. And C is 0, we have to do a complement for it. D is changing, D is going from 0 to 1, eliminated. Let's look at the next one. Let's look at this one. This one is what? A, B. A is remaining the same, A. So we have to do a complement for it. And B is changing from 0 to 1, eliminated. How about CD? CD, since this is happening in same row, CD is the same. So both of them are going to be there, CD. And let's look at the next one. what is changing? A is changing, 0 1 eliminated, B is remaining the same, it's going to be there. CD, since this is happening only in this only one row, the CD is going to be same, CD is going to be there. And then let's look at the last one. Last one we have is, what do we have? Last one we have AB. A is not changing, so it's going to be there. B is changing, B is 1 0 changing, eliminated. CD happening in the same row, so both of them are going to be there. C is going to be there, and D is going to be complemented. Okay, now let's write the expression for the Y. For the first one, A is not changing, but A is 0, I have to do a complement for it. B is changing, 0 to 1 eliminated. C, D is not changing because it's happening in the same row. D is 0, so I have to do a complement for it, and then D remains the same. Now let's look at this one. This one, A is changing, eliminated. B is not changing, it's going to be there. And then CD happening in the same row, so it's going to be the same. CD are 1, so we keep it as it is. Let's look at the next one. A is not changing, so it's going to be there. B is changing, eliminated. CD happening in the same row, so both of them is going to be there. And that's our expression. Now we can go ahead and design this one in PCL. So to design this one in PCL, what we do, we create, we put all the variables. Let me create in a new page. Okay, we have 4 variables. I put a line for all of them. One line for the W, one line for the X, one line for the W, X, Y, Z. Yeah, one line for the W, X, Y, Z. Okay. And then connect a NOT gate with this. NOT gate, NOT gate, NOT gate, and another NOT gate. Draw a line for it. Okay. Let's create, how many expression we have? 1 2 3 4 5 6 7 8 9. Let's create 8 lines. One line, let's use a different color for it. One line, oh shit, okay, let me get it back. Okay, one line, 2 line, 3 line, 4 line, 5 line, 6 line, 7 line, 8 9 line. Okay, now let's bring all the expression we have. You know what, I have to rewrite this W expression here. What is the W expression? Let me write it here. W is equal to CD plus AB bar C bar. CD plus AB bar C bar. And X expression A bar B C bar, A bar B C bar, and then plus A bar CD, plus A bar CD, and then BCD plus BCD, and then we have ACD bar plus ACD bar. That's the X expression. Now let's try the Y expression. A bar C bar D, A bar C bar D, and then we have BCD plus BCD, and then we have ACD. Okay, these are the things we are going to deal with. Let's start from the W. Okay, and also, you know, for these three functions, we have W function, X function, Y function. What we do is we draw a line for those as well. Let's draw it with a different color. Let's say this one is W line. This one is for the X. This one is for the Y. Okay, let's label this W, X, and Y. Let's look at the sum of production expression for the W. What do we have here? We have CD. So it means we have a point at C. This is A, this is B, this one is C, this one is D. We have a point at B right here, and then we, oh shit, that's C, Control Z. Okay, we have a CD, so point at C right here, and then, oh man, that should be on top. Okay, it should be right here, C and D. Okay, that's for the first one, and that's connected with which one? W. So we put a dot right here. And the next one is A, B bar, C bar. Let's write it here. A, B bar, C bar. So A is connected directly with A, B is connected with the NOT gate, and then C is connected with the NOT gate right here. And that is also belong to W. I put a dot right here. And here you have to be careful about this one. You know, you can write these two together at the end and put it two dot in the same line, because these two are equal in expression. That's why we can reduce the AND gates we use for it. Okay, we have dealt with the W. Now let's look at the X. X has A bar, B, C bar. A bar, A connected with the NOT, and then B directly connected, C connected with the NOT. And this is belongs to X function. Let's look at the next one. A bar, C, D. A connected with the NOT, and then C connected directly, and then D connected directly, and this belongs to X. And what else we have? BCD. BCD connected directly, B, C, D. And then what else we have? Oh, okay, let's write the BCD at the end, because BCD is common for both of them. ACD bar next. So I have to erase this thing. Let me erase this first. Okay, so we have taken care of the ACD. Let's go for the ACD bar. ACD bar. A connected directly, and then C connected directly, and then D connected with the NOT. Let's that belongs to X. And last I'm gonna write the BCD. Now B connected directly, C connected directly, and D connected directly, and these are common for two functions, that is X and Y. So you put a dot for X and the Y. And the last one we have is A bar, C bar, D. A connected with a NOT, and then C connected with a NOT, and D connected directly. And then we have BCD we have already taken care of, and ACD, you see it reduces the expression by taking like this. So the next thing is ACD, A connected directly, and then C connected directly, and then D connected directly. And that's how we can design an expression using PLC if we have a given expression like this. Okay, I hope you guys find this video helpful, and this is the PLC. I hope you guys find this video helpful. Thanks for watching. See you guys on my next video.